Welcome to this captivating video, where we'll embark on an intriguing comparison between the refrigerants R134a and R290. Brace yourselves to uncover the fascinating differences between these two. Let's kick off by highlighting that both R290 and R134a are pure gases, capable of being recharged in either liquid or gaseous phase, since they are not composed of gas mixtures. Propane, or R290, serves as a hydrocarbon refrigerant, primarily used in domestic refrigerators, small commercial cooling devices, as well as in low-power air conditioning units and heat pumps. Meanwhile, R134a finds use in equipment of any power range, including domestic and commercial refrigerators, air conditioning chillers for buildings, machine cooling chillers, and automotive air conditioning systems. The primary advantage of R290 lies in its low environmental impact and excellent thermodynamic properties, making it increasingly favored in various applications. R290 is ozone-friendly and boasts an impressively low global warming potential, GWP, of only 3. On the other hand, R134a also doesn't harm the ozone layer, but has a relatively higher GWP of 1,430. As the years pass, this poses challenges due to more stringent environmental restrictions. R290 propane carries a safety classification of A3, being non-toxic but extremely flammable. In contrast, R134a is non-toxic and non-flammable. Although R290 propane is flammable, the risk is reduced, since it is primarily used in cooling circuits with lower cooling capacities, resulting in notably lower quantities of the refrigerant being present. Moreover, R290, like other hydrocarbon-type refrigerants, exhibits excellent miscibility with any type of lubricant, although it is recommended to use lubricants with higher viscosity levels. R134a, on the other hand, is compatible with POE oil in conventional refrigeration and PAG oil in automotive air conditioning systems. Displayed on screen are the capillary tube size tables for R290 and R134a, comparing their cooling capacities side by side. R290 has demonstrated a remarkable reduction in energy consumption in refrigeration systems when compared to R134a. Furthermore, it's crucial to note that R290 and R134a are not interchangeable gases in systems that have already been in operation, unless explicitly authorized by the manufacturer. Using R290 in systems not designed for this gas can lead to instability and adversely affect the compressor's lifespan. Now, let's delve into a detailed study of the specific pressures of these refrigerant gases and their impact on refrigeration systems.
The most used R134a refrigerant gas pressures are 1. To reach a temperature of minus 20 degrees Celsius in the evaporator, equivalent to minus 4 degrees Fahrenheit. A low gauge pressure of 0.32 bars is required, equivalent to 4.70 Cg or 32 kilopascals. To achieve a temperature of minus 15 degrees Celsius in the evaporator, equivalent to 5 degrees Fahrenheit, a low gauge pressure of 0.63 bars is needed, equivalent to 9.26 psig or 63 kilopascals. To reach a temperature of minus 10 degrees Celsius in the evaporator, equivalent to 14 degrees Fahrenheit, a low gauge pressure of 1 bar is needed, equivalent to 14.70 psig or 100 kilopascals. In some cases it is useful to know the pressure of the equipment when it is turned off in the high pressure or the condenser. Let's go see them. For an outdoor environment temperature of 30 degrees C, the equipment turned off at this temperature has a manometric pressure, both high and low, according to the table of 6.70 bar, equivalent to 98.49 psig or 670 kilopascals. For an outdoor environment temperature of 30 degrees Celsius, The condenser temperature is usually about 10 degrees Celsius above the environment where the equipment is located. Thus in the table for 40 degrees Celsius, about 104 degrees Fahrenheit. The high gauge pressure in the condenser is 9.18 bar, equivalent to 134.94 psi or 918 kilopascals. Equivalent to 134.94 psi or 918 kPa. Pressure for low temperature, typical of freezers with a temperature of minus 20 degrees Celsius or minus 4 degrees Fahrenheit. According to the table, we had a manometer pressure of 2.44 bars or 35.86 psi. Pressure for medium temperature, typical of refrigerators, with a temperature of minus 10 degrees Celsius or 14 degrees Fahrenheit. Based on the table, we have a gauge pressure of 3.45 bars or 50.71 psi. Pressure for high temperature, typical of air conditioning, with a temperature of 4 degrees Celsius or 39.2 degrees Fahrenheit. Based on the table, we have a gauge pressure of 5.35 bars or 78.64 psi.